In this lesson, we're going to actually discuss a function type that we've mentioned many times in previous lessons that is called an inverse. Now, we're going to start with just the basic concept of an inverse relation, and then we'll move into the idea of an inverse function. To basically start, though, just discuss inverse relations, and which will then move into inverse functions. We just simply define an inverse relationship as a group of values that we have a domain and a range. And if you just basically flip the domain and range values, you have the inverse part of the relation. And so you can see that if we did this through a mapping mechanism, so if we basically mapped an ordered pair A, B, and we mapped it to B and A, we've just switched the domain and range. If you remember, all of the input values were the domain and the output values were the range. And so if you just switch them, you would have the inverse. Well, if you recall from our unit where we talked about symmetry, what we've done here when we've mapped AB into BA, we've actually created a reflection across the perfect diagonal of y equals to x. And so what you'll see down here in this visual is that we can actually see a relationship inverse through its graph. And if it reflects perfectly over that y equals to x, then we know we're dealing with an inverse relation. So that is a good start in understanding of where an inverse comes from and how it comes about. Now, we'll talk about how it relates back to all of the other functions that we've dealt with so far, and we've talked about inverse portions of different functions along the way, and we'll pick those up as we go. But just to start, this is some good information. Now, if we want to find an inverse relation, and thus a function possibly of a particular problem, what we can do is we can switch the x and the y values and then solve back for the y, and that should give us the inverse relation. So if you look at example 1 here, we basically are giving you y equals 2x minus 4. We know that to be a linear function, so we would switch, and a lot of times this is called the switch and solve method. We're going to switch the x and the y, and you see us do that in the first step. Now the key here is to solve everything back to the y, so we basically have reversed the input and the output values. And you can see we have y equals 2x minus 4. When we switch and solve, we get y equals to 1/2 x plus 2. So that should technically be the inverse function of the original function. Now, we said that should reflect over the y equals to x. So I'm actually going to test this out with our calculator. So I'm going to go to the calculator, and I've already graphed the diagonal y equals to x. And so now I'm going to graph the original function, 2x minus 4. And we can see we get this red graph here. So now I need to test out to see if what I graphed, or when I switched and solved, if it gave me the correct function. So we can see here that if we look at this really closely, if we were to reflect any given point from the original function, the red one, 2x minus 4, across the y equals to x value, we would actually end up on the point of the other graph, or the other function, which is the inverse function. Now, it doesn't have to be a function. It can be any just random set of points, and it would be an inverse relation. But since we have been focused on functions for the most part, that's what we will tend to move into. So now, as we go back to the notes, if we move down into the sample problem number 1, what I'd like you to do at this point in time is just practice the switch and solve method and coming up with the inverse of the given function. So go ahead and try that now. Okay, so you can see here I've used the color to show that I've switched the x and the y from the original function, and now I'm just going to simply solve back for the y. And then from here, to make this look like a normal function, I'm actually going to separate the common denominator and write this out in an appropriate manner. So what we have right here is the inverse of the original function.